The carburetor mixes the proper amount of air and fuel in accordance with the operating conditions of the engine and sends it to the combustion chamber. The principle behind this is similar to that of a manual paint sprayer. When air is blown through the pipe, the liquid inside is drawn up and mixed with the air, forming a spray. An increase in the speed of the air blown through the tube will create to draw up the liquid and create a mist. This is a model used to demonstrate the principle behind the carburetor. Air is blown in at the bottom, creating a vacuum which forces the liquid out. We will explain the functions of the carburetor using this model. First, we will conduct a test in which the nozzle of the fuel pipe alone protrudes into the air tube. If a vacuum is applied to the bottom of the tube, we see that the fuel rises in the pipe a little, but due to insufficient air pressure, enough fuel will not exit the pipe. Now, let's narrow down the mouth of the tube to speed up the airflow and see what happens when we try it again. As you can see, liquid is atomized, that is, changed into a mist that can be blown out through the pipe. This is basically how a carburetor works. The portion that was made narrower to speed up the airflow is called the venturi. Below the venturi is a throttle valve which controls the air-fuel mixture. It is connected to the accelerator pedal. These comprise the fundamentals of the carburetor. This is how the air and fuel are mixed, but it leaves us with one problem, namely how to achieve and maintain the proper mixture of air and fuel, or the correct air-fuel ratio. Theoretically, the optimum ratio for combustion is 14.7 parts of air for every 1 part fuel. If this theoretical ratio is achieved, the result will be easy engine starting and complete combustion. As long as a mixture at this ratio is supplied by the carburetor, the engine will run smoothly. Now let different driving conditions beginning from when the vehicle is started. Naturally, the engine is cold, making it harder for the fuel to be atomized. This alone is enough to create an improper air-fuel mixture. Hence, it is necessary to provide a greater ratio of fuel to air. Just when the vehicle is accelerating, we know that fuel is heavier than air, so since the amount of air is increased when the accelerator pedal is pressed, the amount of fuel also must be increased to obtain sudden acceleration. When the engine is idling, or when the vehicle is traveling at low speeds, fuel and air do not mix well. Because of this, it is necessary to achieve the theoretical ratio, or a slightly richer mixture. A greater ratio of fuel to air is necessary to obtain the needed power when climbing hills, or other times when the throttle valve is wide. The theoretical air-fuel ratio, or a slightly leaner mixture, is needed when driving on straight even roads at constant speeds. So as you can see, the carburetor must create the proper air-fuel mixture under a variety of driving conditions. Although there are many types of carburetors, we will examine the workings of the carburetor used for the 4AF engine. This carburetor is called the double barrel type because it has 2 passageways, or barrels, for carrying the air-fuel mixture. This is the primary barrel, and this is the secondary one. The air that passes through the air cleaner enters the barrels here. The fuel from the fuel pump enters the float chamber here.